Alright, these are the even homework problems for 9-4 mathematical induction. So problem 6 is the first one we'll tackle, and we're asked to find p of k plus 1. So everywhere we see k, we put in a k plus 1. So 1 over 2, and there's only one spot that we need to substitute here. This k turns into k plus 1. And we still have a plus 2 there. So we can just clean that up to get our final solution. 1 over 2, k plus 3. And yes, we could distribute this, but we want our final form here to look as much as possible as our original form here. So we're just going to leave it like this. 1 over 2 times k plus 3. All right, next one, we're going to actually do some mathematical induction for problem 12. All right, so there's going to be 3 parts. There's the original. Oh, excuse me, jumping one step ahead. First, before we do that, we have to prove that this works for n equals 1. So the first term is just 3, so we're going to grab that and make that equal to the right side of the equation, substituting in 1 for n. So instead of n, we'll put 1. Instead of n, we'll put 1. And then let's simplify this and see if it worked. 3 on the left still. 2 times 1 is 2. Plus 1 is 3. Times it by 1. And that is definitely true. So we've proved it for 1. Now we have to prove it for n plus 1, the next one in our list. All right? So we've got our original list. That original list on the left side is 3 plus 7 plus 11 plus 15 plus all the way up to 4n minus 1. Plus, we need one more term. 4n plus 1 minus 1. Just replacing n with n plus 1. And we're going to make that equal to n plus 1 and to n plus 1 plus 1. All right, so we added one extra term here, and that's equal on the right side to, instead of n plus 1. All right, so let's clean this up a little bit. This is 4n plus 4 minus 1 is plus 3. I'm going to drop this whole part right here and substitute in the original. Originally, the left side was equal to n, parentheses 2n plus 1, so it's still going to be equal to n 2n plus 1 plus. All right, so this part that I'm putting a rectangle around turned into this, and then this part here cleaned up into this. So let me just multiply this out. We've got 2n squared plus n, just distributing, plus 4n plus 3. And so all together, that's going to equal, let me erase this up here so we have a little bit of room. That's going to equal 2n squared plus 5n plus 3. What is the right side equal to? Well, let's clean this up real quick. This is n plus 1. And then it's 2n. That's a 2 plus 1 more plus 3. Let's FOIL this thing. First, 2n squared. Outside, 3n. Inside, 2n. And last, plus 3. And look what we have. Let's clean that up, collect our like terms. We have the exact same thing on the left as we do on the right. So we have proved this using mathematical induction. Let's try it again for 18. So first things first, let's prove it for n equals 1. So 1 cubed, just the first term, is going to equal 1 squared. 1 plus 1 squared over 4. That's 1. 2 squared is 4. So 4 over 4 does equal 1. We've proved that for 1. I'm going to go ahead and erase this just so I have the space. But now we're going to solve it. Part 2, we're going to do it for n plus 1. So part 2, we're going to say the original equation, 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus all the way out to n cubed plus n plus 1 cubed, that additional term, equals n plus 1 squared. N plus 1 is going to be n plus 2 squared over 4. Alright, so let's clean this up. This part here turns into n squared, n plus 1 squared over 4 from substitution. We still have the n plus 1 cubed, and it equals n plus 1 squared, n plus 2 squared over 4 still. Alright, let's get rid of some fractions here. So we're going to multiply this whole thing by 4. So we'll end up with n squared, shred it out, times 4, n squared, n plus 1 squared, plus 4, n plus 1 squared, cubed, equals n plus 1 squared, n plus 2 squared. Alright, so we have to prove that the left is equal to the right. This could involve a whole lot of foiling, and you could go through it that way and get it. Or you could look at factoring by grouping, and that's going to be the faster way to do this. If we can realize that n plus 1 cubed is the same as writing n plus 1, and then another n plus 1 squared, we'll see here that both terms have an n plus 1 squared, so we can factor out n squared plus 4 n plus 1 times n plus 1 squared equals n plus 1 squared n plus 2 squared. And so these things show up on both sides, so we'll get rid of them. Let me erase the top line to create a little more space to keep going. Okay, so if we loop back up to the top here, now we've got n squared plus 4n plus 4, I'm just distributing here, okay, equals n plus 2 squared. And so now we can just FOIL this last step. N plus 2 squared is going to be n squared plus 4n plus 4, and that is exactly what is equal on the other side. So we've got it. Alrighty. And 24 I said you did not have to do. We're going to skip all of these going through. And so the next one that we have to do is 54. So we're going to find the sum using these formulas. All right, on your worksheet we had a formula for n to the 5th. And I'm going to grab it here. N to the 5th formula is n squared, n plus 1 squared, 2n squared plus 2n minus 1. And take the whole thing and put it over 12. And then, so we're going to substitute 8 in everywhere we see n. So 8 squared, 8 plus 1 squared, 2 times 8 squared, plus 2 times 8, minus 1, all over 12. And so let's clean this up. The 8 squared is 64. 8 plus 1 is 9, squared is 81. 8 squared is 64, times 2 is 128, plus 16, minus 1, all over 12. And so go ahead and punch that into your calculator. 61,776 is the answer that you should get. All right, last even one is problem 60, and we're going to decide whether the sequence is represented by a linear or a quadratic model. The way we're going to do that is with the first and second differences. So from 2 to 9 is a difference of 7. and 7, and 7, and 7, and 7. This is our first difference. Since they're all the same, we're done. This is a linear model. Let's go ahead and figure out what it is. A linear model is the same as saying an arithmetic model. So we can go to a sub n equals a1. We have this formula plus n minus 1d. A sub n, the first term is 2. The difference is 7. Let's distribute and clean this up. Plus 7n minus 7. And so our final answer, a sub n, will be 7n minus 5. And that's our answer. That's our linear function. So try the other problems and questions. Ask me in class.